Hey everyone. So today we're going to cover all of Unit 7 because it's kind of a short one. And actually a lot of it we've already covered in quarter 2. So to do this week, you should watch 7.1 through 7.8 on the College Board videos. And then also that way you can finish your Unit 7 progress check. So this week's a little bit more crunched. But your overview, I'm going to do a quick overview of 7.1 through 7.8 concepts. And of course, we are on Liz John Aloni people land. Okay. So look at this awesome little thing I found. Hey, I heard you're doing your best, even though it's hard. Whoa, you're amazing. Okay. But today the Unit 7 is all about air pollution. So parts of it should come as a review for you after quarter 2. Okay, so we'll roll through all the way to noise pollution. All right, so let's start out. Intro to air pollution should be something that you're familiar with, but I'll highlight a couple of things that they want you to know. So, of course, human activities have physical, chemical, and biological consequences for the atmosphere. Kind of a duh. And then here's a little, like, what are the sources? Let's remember, like, sources of pollution. So some vocabulary that they want you to remember is primary versus secondary pollutants. So remember, primary are the pollutants that we release directly into the atmosphere, while secondary are the pollutants that are mixing in the atmosphere and create new ones, right? So these are the result of the mixing and the result of the creating that new pollutant. A little bit of history they want you to know. Oops, let me finish that sentence. There we go. Okay, so one of the significant parts of legislation that was passed for air pollution was the Clean Air Act of 1970, which was big, and then the Environmental Protection Agency. So both of which regulated the use of lead in fossil fuels, and so it significantly decreased the amount of lead in the air. Not sure why that is a tidbit the AP test wants you to know, but that's one of them. Okay, so to get into it, we have photochemical smog, and y'all know this one. But essentially, photochemical smog is nitrous oxide, so NO2 or NO3, mixing with volatile organic chemicals, VOCs, and then in addition to like UV light and heat, that's what creates the photochemical smog. So that's the smog that lays over the Bay Area, over like most of the Central Valley, LA, anywhere that's super populated. So you can see here, like the primary pollutants, like we talked about before, are the nitrous oxides here, and then volatile organic chemicals. And there are natural sources in which they come from, like VOCs do naturally come from trees, plants, and then also volcanoes release nitrous oxides. However, the majority of it that causes photochemical smog at the rate that it exists come from cars and boats and like industrial things. So to look a little bit more closely at NOx emissions, you can see that most of it comes from the on-road, non-road sources, such as cars, trucks, and trains. So 58% of that. Stationary fuel combustion, meaning like in power plants and whatnot, 30% about, and then industrial processes, about 10%, 3% miscellaneous. Okay, so volatile organic chemicals, where do those come from? Mostly from industrial processes and product use. So from a variety of different sources, but mostly industrial. And then you can see the other ones here. The second largest is household and commercial use. And then of course, heat comes from the sun. And so it is important to note, which I think I talk about in the next slide, but it's important to note that like, photochemical smog, like we kind of studied in quarter 2, is the most intense when it's like hottest. So usually in the afternoon. So, and then also like during the summer months, it's going to be worse. So The spike in photochemical smog is in the afternoons in the summers because that's when it's hottest. It often forms in urban areas where there is a lot of like NOx and VOCs being emitted. And then it is, of course, it is harmful to human health. So it leads to a lot of respiratory problems if you're exposed to it over long periods of time. And then obviously like eye irritation and all of these other things. All right, so to keep rolling, the next topic they want you to know about is thermal inversion. And so this is about temperature. And so let's look over on this left side over here. So in like under normal circumstances, you have warm air towards the bottom, towards the city, because as we learned, I think it was unit 5. Unit 5, you learned that like cities tend to be warmer than like places where there is a little bit more natural like trees and land that has not been paved over. So you have this warm air near the city, and then as you get colder, as you get further away, it gets colder. And so like we learned in unit 4, warm air rises, right? And so, which is good because then all of this pollution, like all of these like brown dots are air pollution. At night, warm air is going to rise, well, throughout the day, but especially at night when it gets colder, warm air is going to drastically rise, and it's going to kind of take the air pollution away into the atmosphere. And then it kind of like moves in different directions, depending on the wind patterns. So this is good where it takes away air pollution. Now, sometimes, so thermal inversion happens when like it naturally occurs oftentimes when different systems move in. And so you can see here, especially in like high elevation places, sometimes there can be kind of like this warm air layer that moves in. And it's also like from air pressure, so different weather systems. But when this happens, there is like an interrupting like warm air layer here. And so then you have all of this warmth that is generated by a city or an urban area, and it can no longer escape upwards and mix with that like upper layer of the atmosphere. And so because of that, you can see all of this air pollution starts kind of getting trapped below down here. All right, so that's what a thermal inversion is. Like one of the products of it is that the air pollution kind of like sits on top of the city instead of being able to like rise and mix with the upper atmosphere and kind of like leave the city. So it's especially apparent when there is smog or particulate matter that gets trapped. All right. Okay, so that's thermal inversion. So one of the sections is atmospheric CO2 and particulates. And I'm going to go over that pretty quickly because pretty broad strokes, but it seems like two like topics that they kind of threw together, but we'll focus on atmospheric CO2. And so to harken back to us talking about the carbon cycle, we're focusing on just like the atmospheric part of the carbon cycle. So in this, I wanted to show you this because to give you a scale of like where carbon is and how it gets exchanged. So of course, we want to remember way back to unit 1, like global, all of like the primary production that happens. And so over here, all of these numbers are talking about like the amount of carbon that gets transferred. So, vegetation takes in 120 atmospheric CO2, and then also puts back 119. Sorry, I need to plug in my computer. Same with the ocean, the exchange is 88 to 90. And then one thing that we want to keep in mind is, so these blue arrows are naturally occurring and they're pretty constant, right? So they're like pretty even. But however, we want to remember that like we are the ones adding in this extra bit of CO2. And it's not a little bit, it's a lot, right? We're adding in on a scale of like 6.3, which is a lot when we're not taking in any CO2. All right. So this is just kind of to show you how much CO2 we're adding into the environment. Okay, and then particulates, we kind of talked about in Q2, but we glossed over it. So particulate matter is a very broad concept. Essentially, it's anything that it's like tiny objects that are aerosolized. So aerosolized meaning they're in the air. So like they range in size. So there's particulate matter 2.5 here, which is a really, really small one. So you can see here it's 2.5 microns in diameter. Particulate matter 10 is kind of like dust, pollen, or mold. It's a little bit bigger, so it's 10 microns in diameter. And of course, we want to keep in mind that the 2.5 is the one that's more damaging because it's smaller. So it can get lodged into, like, when you're inhaling it, it can get lodged into smaller places in your lungs, which is more dangerous. So we also want to remember particulate matter is like, it comes from everywhere, right? Like, and so that's not to scare you, but that's just like the reality where it comes from all of these different places. It comes from the water, it comes from the air, it comes from like your surfaces. It is dust. It is like if you're frying up food, it gets like into the air via cooking. And so these exist all over everywhere. All right. Okay, so segue is indoor air pollutants. I do want to talk about a couple of the ones that they want you to know in the AP test. So the first one being carbon monoxide. And so a lot of you probably have seen these alarms in your house. And so these alarms, they sense CO, which is carbon monoxide. It's an odorless, it's caused by fuel burning appliances like stoves, washers, and water heaters. So if there's like something wrong with one of your appliances or something that burns fuel, then it can cause a carbon monoxide leak, which is deadly in like high doses. And so this picture here, so I took these slides from last year and I showed this picture because oftentimes in like ghosts shows, like where people are like ghost hunters or something, where people are like going to people's houses and like checking out. Oftentimes there's a carbon monoxide leak in somebody's house. And so like one of the symptoms of like carbon monoxide poisoning is like you start feeling like this like overwhelming dread and this like kind of like paranoia, and like you start kind of hallucinating a little bit. So I thought that was an interesting thing about carbon monoxide that might like help you remember it. Okay, so another one is lead. So lead is often, lead is one of those materials that's like outdated that we no longer use, but we used it in fairly recent history, so it still lingers in certain parts of our infrastructure. So like one of the big things, it's found in old plumbing pipes, fixtures, and paint in houses built before 1978. So like fairly recently, I think the apartment I lived in is built before 1978. So technically, like all houses should have been checked by now for lead. And it causes neurological damage, anemia, which is a red blood cell disorder, and then also like miscarriages and like all sorts of other symptoms. And so this, I'm highlighting, so obviously this is the pipe, but I wanted to highlight this picture because when I talked about this last year, we also examined the Flint water crisis, and that was, I'm sure that you remember it, but it was a Flint, Michigan. There was a huge, a citywide, oh my God, I'm like blanking on the word, but basically citywide, there's, they found lead in a lot of the water sources. And so there was just like a water shortage. People were relying on water bottles, didn't have enough water, and there's a lot of health side effects from it. So lead is a really serious one. Okay, and then there's radon. So radon is a gas. It's colorless. It's an odorless gas that is naturally occurring. So this happens. So it occurs during decay from product as a product of uranium. So this is like it occurs in the ground below you, um, and it's radon's one of the leading causes of lung cancer in the U.S. And it's insidious because it's colorless and odorless. And so what happens is like radon, because radon is a gas, when it's released it can go like anywhere, right? And so what happens is there's bedrock here, and it's especially happening in place it happens in places that are geologically active, and so like places in the west. So what happens is maybe there's like an earthquake or like there's a big shift. Maybe it happens when there's fracking in the area. And so it releases like because if there's a big shift or some kind of movement, it'll release this gas. And then if there's like a house or if there's infrastructure or like a water well nearby, radon will get into the water or into the house and whatnot. All right, so the last one is called asbestos. You might have heard this before, but asbestos is a naturally occurring fibrous silicate, so it comes from silicon material. Exposure to fibers is known to cause lung disease. So how this happens is asbestos at one point, I think in the mid-century, like mid-century, maybe 1900s. But decades ago, they discovered asbestos as like this very, very solid building material, and so they started making like everything out of asbestos. So like a lot of houses were built with asbestos. Even like books and stuff had asbestos in it, and then they started realizing that asbestos causes this lung disease. So why it's so deadly is you can see that like although it's naturally occurring, asbestos is just like a bunch of tiny fibers. So it's like a bunch of like teeny tiny like needles essentially, very, very small when broken down, but that's also what makes them it so dangerous. And so obviously you can imagine like, you know, uh, inhaling this material can be very damaging. All right. But it's like lead where like most buildings should not have asbestos anymore. Okay. So to move away from indoor air pollutants, I want to move into air pollution reduction methods for industries. So 7.6 focuses on reduction of air pollutants. So like different strategies that we've come up with. Now, one of them is called the vapor recovery nozzle. So at gas stations, if you pay attention, you'll see that this is what a vapor recovery nozzle is. And what it does, it prevents fumes from escaping into the atmosphere when refueling a motor. And so this helps that. And so most gas stations will have this nozzle now, which is cool. Okay. And then these are kind of like you have to memorize these, unfortunately. These I have like there's like 4 different ones, but these are the ones that the AP test finds important. And then there's the catalytic converters, which came about in the 1975. And so what it does, catalytic converter, essentially, it's a device that is installed into your car. And like oftentimes cars have it, other motorized vehicles obviously have it too. But it's a device for internal combustion engines that convert pollutants and exhaust. So these harmful exhaust gases that your car produces, and it converts them into less harmful molecules up right here, right? So that's one of them. Another one of them, now we're going to scale out away from cars into like industrial like power plants and like buildings. So there's the concept of scrubbers, which scrubbers, it's like this, it's a whole like mechanism. So they call it scrubbers. But essentially scrubbers remove particulates and or gas from industrial exhaust steams. So it's essentially like kind of a filter that like industrial power plants or like manufacturers will install in order to reduce the amount of pollution they're putting in the air. And so there's 2 different types that I want to introduce. There's wet scrubbers, which essentially they're using water to like to perform this like filtration essentially, but it introduces the dirty gas steam with a scrubbing liquid, typically water. And so you see here, um, and then the particulate or gases are collected in the scrubbing liquid. And then generally the most appropriate device for collecting both particulate and gas is a single system. So essentially, like you can see here, the contaminant gas comes in and it meets this liquid reservoir. And so then it goes through all of these different mechanisms in order to filter out the things, the contaminants in it. And so when it is released, it is a lot cleaner. Okay. So then, like, obviously on the flip side, there's the dry scrubbers as opposed to the wet scrubbers. And essentially, this uses a different mechanism. Instead of using liquid, it uses dry reagents. So like, it essentially uses chemical, like neutralizing chemicals that are sprayed into an exhaust system. So the pollutants are neutralized or they react and turn into a different substance. So like if it'll, like the contaminants will come in, the dry scrubbers will spray some sort of reagent that will kind of like diffuse the toxicity, and some kind of chemical reaction will happen so that it becomes less, oh my god, less toxic. So that substance then falls out of the gas stream or is caught in a particulate stream. So basically, like you can see, once it's neutralized, the toxicity part will come out and it's collected. Okay, so for example, I'm going to name a type of scrubber. So there's the electrostatic precipitators, and this is important. They want you to know this one. So with the electrostatic precipitators, how it works is you get these dirt particles, and they gain a negative charge from one wire or plate. So one of these, before being attracted to a second wire or plate, one of these, with a positive electric charge for collection and disposal. So essentially, like you see the incoming gas particulates are then sucked onto the metal plate, for a lack of a better term, but basically using the attraction and the like using physics to kind of dispose of these particulate matters. So this is a scrubber. So would this be considered a wet or dry scrubber? And so this electrostatic precipitators, this is they put these in coal burning power plants, and this is a dry scrubber because it does something to neutralize the particulate, but it does not use water. Okay, so moving on from those very specific air pollution reduction methods is acid rain. So this is something we studied in class, so it should be review, thank God, right? But okay, so acid rain obviously is rain that is slightly acidic, right? And so we want to remember that rain should be neutral, and so it should sit at a solid 7 on the pH scale. However, with acid rain is formed because of all of the pollution that we put into the air that mixes. So now sulfur dioxide, SO2, that is a primary pollutant, right? So it's released from like power plants and cars. It's released directly into the atmosphere. So primary pollutant, then it mixes with the oxygen that's in the atmosphere, right? You have a bunch of O2 molecules floating around, and then 2 of these sulfur dioxide molecules bump into them. And obviously with the sun as a catalyst, it becomes sulfur trioxide. So it rearranges itself. So then you have 2 molecules of sulfur trioxide. Great. That should be okay. But then the sulfur trioxide then mixes with some water vapor. And that water vapor, then they are further, the sun is still there catalyzing the reaction. And then what happens is when it mixes with water, that's when it becomes the more toxic and dangerous air pollutant, which is sulfuric acid. And so the sulfuric acid is the product. So that's the secondary pollutant that happens. So remember, sulfur dioxide is the primary pollutant. So now we have sulfuric acid in the atmosphere. And of course, when it rains, it's going to rain down the sulfuric acid. And so that's how acid rain forms. All right. Cool. Okay. Our last one is noise pollution. So noise pollution is something I didn't touch on quite as much in quarter two. I think I mentioned it when we talked about deep water oil drilling. So some sources of noise pollution is literally just like man-made sounds, right? Or just like large sounds. So like it comes from transportation. You know, people that live close to the airport will hear like airplanes a lot more and a lot louder. Obviously construction. I think we all live by construction. And then domestic and industrial activities. Duh. Okay, so we know the risks of noise. It can be damaging. So this is like a quick scale of like decibel level. So leaves rustling all the way to like a rocket launch. And so when it's starts to become damaging and whatnot. So if you want to pause the video, look at this, go right ahead. Okay, so some harmful effects that it can have. So noise pollution at a long-term exposure to noise pollution and also like intense, like high decibel noise pollution can lead to negative effects. So like cognitively, difficulty in speech development, impaired language comprehension, poor memory and reading ability is one of them. Other things that happen physically, there can be hearing loss, raised blood pressure, endocrine imbalance. Endocrines are your hormones. And then behaviorally, stress and anxiety, lack of motivation, hyperactivity. So that's in people that have high exposure to like lots of noise pollution. And obviously this is a generalization. Okay, so if you want to focus on outside of humans, the organisms, so obviously if you think about the near Lake Merritt, the creatures that live there obviously are experience more noise pollution than say the lake that is like 50 miles north of us in the mountains, right? And so I'll start on this side. Stress, obviously it stresses out organisms. Masking of sounds used to communicate or hunt. So like it could like if, for example, like coyotes who use sound to navigate, or like bats that use sonar, it could interfere with that. Obviously it can damage hearing just like us. And then changes in migratory routes is huge as well, because a lot of organisms depend on sonar for migratory routes. And so if that gets interfered by like noise, by noise and sound waves, that is also detrimental. So like in the air, birds can adjust how they sing and try to be heard over noise. Some change their pitch and try to sing at night instead of during the day. And then birds can often have a hard time finding food in noisy areas. Oh, and then like, so it's hard to hear predators oftentimes. And then when it comes to in the ocean, human noises can cause hearing loss in dolphins and porpoises and whales. And this is the one where they have like oil and gas exploration and ships disturb migration routes. And then for octopuses and squid, it can lose their sense of balance, affecting their ability to hunt. So marine ecosystems definitely are very affected by noise pollution. So you can see, and I say marine life is especially because when we navigate through the ocean, we oftentimes use sonar. So like commercial shipping vessels, survey vessels, all of these use sonar, which is where you send waves into the water, and then the way that the waves bounce back tell us what is in the water. And so like those waves obviously will interfere with marine life communication and migration. So these are a couple of news articles that I picked out. So there was like in 2019, there's a underwater pile driving noise causes alarm response in squid. Dolphins struggle with noise pollutions. Ocean uproar saving marine life from the barrage of noise. And so this is like definitely like makes headlines, and it's an issue that exists, widely exists, I should say. Okay. So that is that. So wow, that was unit 7. I breezed through, and I left out things like, what are the effects of acid rain, because we did cover it in quarter 2. But if you have any questions next week, you can ask them during our Q&A, or you can just ask them right into the Discord chat. So this week, obviously watch this video, which you already did, and then watch the AP College Board 7.1 through 7.8 videos, because they'll go into more depth about it than I will. And then hopefully if you will work on your Unit 7 progress checks, multiple choice and FRQ. All right, thanks for watching, y'all.